All right. Good afternoon, ladies and gentlemen. We usually have our seminar series in the morning, but this time it's in the afternoon. Welcome to the Ateneo de Manila University, Department of Economics, and Ateneo Center for Economic Research and Development Seminar Series. Before we start, let me just give you our house rules for the seminar. For those of you who are new, let me just remind you, we will let the speaker finish her presentation first before we entertain questions. Zoom participants, kindly stay muted and stop sharing your video during the duration of the presentation, except of course our speaker. During question and answer, please virtually raise your hand and wait to be acknowledged. Please also tell us your institutional affiliation. You may unmute and show yourself when asking your questions. Participants on Facebook, please post your questions in the comment sections and we will read them out for you. Please also let us know your institutional affiliation. Slides, videos, and other materials from the seminar are posted on our website only when the speaker gives their consent for sharing them. And this afternoon, our speaker is giving her consent. We are very pleased to have Dr. Divina Gracia Rodriguez, or Ivy. She is a research scientist at the Department of Economics and Society at the Norwegian Institute of Bioeconomy Research. Her research relates to environmental, consumer, and production economics in both developing and development market contexts, with focus on food security and agricultural productivity. Currently, she is involved in several research projects, development and innovation projects such as Obtain, which investigates optimal strategies to retain and reuse water and nutrients in small agricultural catchments, among other innovative projects. Her research and development experience include in the countries of Cambodia, Denmark, France, Ghana, India, Greece, Malawi, Norway, Philippines, Poland, Romania, Senegal, Vietnam, and the USA. She earned her PhD in Agricultural and Applied Economics from the University of Illinois at Urbana-Champaign in 2014. This afternoon, she is here with us to present her research on the site-specific nutrient management strategy for rice and macroeconomic analysis. Let us welcome Dr. Ivy Rodriguez. Ivy, the virtual floor is yours.
Thank you, Ate Maha. This will stop. I will need to share my screen. Okay. Can you see my screen now?
Yes.
Okay. Just a second. I will just move here. Okay. Good morning, everybody. Let me just hide the videos. Okay, good morning, everyone. My research is about the site-specific nutrient management strategy for rice. I actually worked in Erie from 2006 to 2008 after my MS, and this is about its microanalysis of Ssnm. So, why Ssnm? Rice is life. I think for most of us, you will agree that rice is life. Rice for breakfast, lunch, and dinner, and maybe sometimes snacks. Rice is an important staple food for about 70% of the Asian population, nearly 3 billion people, and more than 75% of the rice worldwide is produced in irrigated rice lands, and 90% of these irrigated lands are paddy rice found predominantly in Asia. So rice requires essential nutrients such as nitrogen that are typically not present in soil in sufficient amount to meet crop needs. And rice production alone uses 16% of total N N fertilizer and 15% fertilizer worldwide. However, fertilizer recommendations typically do not consider field, climate, and management site-specific effects on the nutrient needs of crop. Therefore, to ensure that nitrogen and other essential plant nutrients are provided in optimal amounts and are readily available during crop growth stages, site-specific nutrient management, or SSNM, was developed in Asia by the International Rice Research Institute. So what is SSNM? So SSNM is a low-tech approach for feeding rice with essential nutrients when they are needed. And it says optimal use of existing nutrients such as from soil, residues, and manure. And the aim is to apply the optimal amount of these nutrients to maximize yield, which is different from economist perspective, which is to maximize profit of farmers. And at the same time, it offers proper timing and splitting patterns for fertilizer applications. So for N fertilizer, what SSNM does is it calculates the optimum amount to be applied and then further determines the appropriate distribution of the fertilizer through the growing season to match the peak demand for N by the crop, depending on the needs of specific crop types and varieties at key growth states. And then Ssnm, so strategy requires information on one, farmer's yield goal or yield target. And then when you have that, you will have an idea how much total crop requirement of N are needed. And then you will also need information on the endogenous supply of nutrients in the soil. And then when you have these two, then you will be able to fill deficit between the total needs and the endogenous supply. And that is what is recommended to farmers to apply. So where is SSNM practiced right now? So it is practiced in Bangladesh, Indonesia, Philippines, which I heard is already turned over to the Department of Agriculture, and India, and there are also, it is also practiced in China and West Africa using the Nutrient Manager for Rice. It is a computer and mobile-based application that provides farmers with fertilizer advice matching their particular farming conditions. But in 2013, this nutrient manager is converted into a web-based rice crop manager, or RCM, which provide advice on crop management practices in addition to nutrient management. And this is an example of a field-specific fertilizer recommendation provided by the RCM for the Philippines. And as you can see, it shows here the different crop growths and its days after planting. And then for each crop stages, there's a corresponding fertilizer requirement recommendation to be applied to rice. So now, how is fertilizer recommendation determined using the SSNM approach? So this is the formula that the SSNM formula, where f of x is the amount of NPK recommended. So this is computed individually. And then YG here is reflection of the total amount of NPK that must be taken up by the crop to achieve the yield goal or yield target. And then this variable is the X nutrient limited yield or grain yield attainable from the endogenous supply of nutrient. And then UX U prime X is just, it's a constant. It's the optimal X uptake requirement to produce a ton of grain yield. And then this is just the agronomic efficiency of fertilizer X. So this algorithm is very simple. But what do you notice about the formula? The Ssnm approach does not involve rice or fertilizer practice. And from a technical microeconomic view of crop response, some restrictions must be met for the Ssnm approach to be a profit maximizing algorithm. So I argue that yield potential or goal methods make economic sense if prices do not matter. And that implies the production function is linear von Liebig. So, and it also reflects the law of minimum. And the law of minimum says if a soil is deficient in, say, N, then yields will be unresponsive to increases in P and K, as is the case for a Leontief production function. So here, I show figure 1A is the isoquants under Leontief technology. The isoquants is a locus of points, just a quick review, representing the various combination of two inputs to produce the same output. So here, the isoquants of the crop production function as shown here in figure 1A. Here we have N on x-axis and K or potassium on the y-axis. Will have a vertical and horizontal legs that join at right angles, and the von Liebig production function, when charted as dependent on N here in figure 1B, will be kinked here. So farmers, in this case, it implies a linear response and plateau model. And in this case, allocation under profit maximization, relative input and output prices can be ignored in the fertilizer algorithm. And if this is the case, then the economic optimal N rate that will both maximize yield and profit is the minimum rate at which the yield reaches its plateau. So farmers can either choose 0N or in this plateau. And then, okay, so with that, my first research question is that, is there evidence of complementary or von Liebig type relationships among NPK? Does price don't matter? Because economists tend to think that output and input prices affect farmers' production decisions. And here, I just want to show you the effects of relative price change on optimal N rate. So on x-axis is the N and y is the yield. And let's say the WP is just the input and price ratio for rice. And say, if this is the price ratio and this is the production function, if it's not linear plateau model and if it's a quadratic function, then the economic optimal N rate will be at this point where it is tangent, the ratio is tangent to the production function. And let's say that the input price is constant at W. But what if we increase the price, let's say from 30, we increase the output price of rice to 50? Then the new economic optimal N rate, the farmers will need to apply this rate of N to achieve this Y. But what if, again, we reduce the price of rice to 20 pesos? So here, the economic N rate will be at this point. So if it is not a von Liebig function, then we cannot ignore prices. Moreover, existing Ssnm algorithm does not consider explicitly the possible relationship of N fertilizer and soil organic matter based on this formula. And SOM is reflected in soil carbon contents, which is recognized as the single best summary statistic for soil fertility status associated with soil organic matter stocks. And actually, a few studies have shown that increasing the soil organic matter makes fertilizer application of N more effective and can improve crop yields. So given that, I hypothesize that the marginal product of N, hence the profitability of N fertilizer or any fertilizer, depends on soil C stocks, which may vary systematically in farmers' field. And then as an initial test, I just plot the carbon and the rice yield, carbon on x-axis and rice yield on y, and it shows that yield increases as organic carbon increases. So hence, my second research question is, does yield response to N fertilizer application depend on the initial state of soil? So this paper contributes to the literature by providing a broader scope of analysis of Ssnm in irrigated rice systems by exploring the interactions among nutrients and between soil organic matter and applied N fertilizer. So to answer this question, I used the data on irrigated rice production and input use from IRRI on project reversing trends of declining productivity in intensive rice irrigated systems carried out in 8 locations in 5 countries across tropical and subtropical environments in Asia. So we have 2 areas in India, Tamil Nadu, Uttar Pradesh, Indonesia, Philippines, Thailand, and Vietnam in the Mekong Delta and Red River Delta. And then in each of the 5 countries, the data originate from both nutrient omission and fertilizer evaluation trials conducted in farmers' fields, and the treatments there were 4: no fertilizer, meaning no fertilizer applied, so 0N, 0P, 0K, and then there's a PK applied, 0N, and then Ssnm itself, and then the farmer's field practice with no interference or intervention by IRRI. And all data for irrigated rice whereby water rarely limited plant growth. And each experiment was run for 3 to 5 years, but due to data availability, I only used data for 1 year in some areas and 2 years in other areas. And each treatment contained 2 to 3 replicate sampling plots per farm. And then farmer and site selection criteria by IRRI is this: the sites represented the most common soil types, and then it represents the most cropping systems and management practices, a range of socioeconomic conditions, so small farm, big farm, rich region, poor region. Sites allowed reasonable accessibility for frequent field visits, and farmers were interested to participate over a long term. So methodology here, I use the quadratic function. The rice production function for each experimental site can be defined by using a generalized quadratic specification. So here, where y is the grain yield and x is just the vector of independent variables, which is nitrogen, phosphorus, potassium, carbon, age of farmer, education, and farm area, and a dummy for high yielding season. And beta here is the vector comprises the parameter estimates of interests, and E is the error term. So I'm actually interested on this beta ij. So this will show the interaction of nutrients. So I tested that hypothesis. So to explore the relationship among fertilizer NPK application and the ex-ante soil fertility in each site, I tested the null hypothesis that NPK fertilizer do not significantly interact with each other and that the soil C content has no indirect effects on yields through N fertilizer application. So if we cannot reject the hypothesis that then there's an independence of Xi and Xj, but if we reject and the beta ij is less than 0, then nutrients are technically complementarity, and that indicates one Liebig. It means the marginal product of N, for example, increases as P increases. But if it's negative, then they are technically substitutes, and price would matter here, and increasing Xi reduces the marginal product of Xj. And then I also tested, so what is the correct functional form, or what is the correct crop nutrient model? And to determine that, I performed the non-nested hypothesis framework, which I will not discuss here. It was proposed by Davidson and McKinnon, and I contrasted the quadratic model against 3 alternative hypotheses, which is the linear von Liebig, which is what I presented earlier, and then the non-linear von Liebig, so it's just curvy and then it flattens out also, and then the square root model, which is almost the same as the quadratic function. So results and discussion. So here I will not discuss this because this will just be the basis of other discussion. So here I have I will only discuss significant results. So what I first did is the production function estimates using 2 versions of the quadratic model in each of the 5 countries. And I favored model 2, where I have as control variables the nitrogen and is NPK, and it is squared terms, and then the interaction of N and P, PK, N and K, and organic C and N, and all the high yielding season dummy, farm area, and farm area squared. Yeah. So using those estimates from the production function, or using those regression results, I estimated first the marginal physical product and output elasticity at the mean level for each variable for the entire sample plots in all locations. But here I'm just presenting 2 locations. Those does have interesting results. And here we can see that the average physical product for N fertilizer application was positive, and the output elasticity value was less than 1, meaning there's a decreasing returns to scale. And it also suggests that the additional N fertilizer use had a significant positive influence on the yield in most plots in the sample. And then another interesting result is that here in Vietnam, there is a negative marginal physical product of K, or potassium, in Kanto. And Ssnm approach takes into account the amount of K recycled with straw yield and the straw management level in the previous season when calculating K fertilizer requirements to avoid excessive K fertilizer. However, from my understanding, it does not consider the abundance of digestible nutrients in the soil, and the water from Mekong River Delta has high content of sediments which provide nutrients for crops. So here, I would interpret this that the additional K fertilizer would not be beneficial and may result to over-fertilization or the negative marginal physical product. So, and when fertilizer is over-applied, this may result in the formation of an excess of soluble fertilizer components in the soil and their increased leaching. And here, what I did here now is I graphed the marginal physical product of N against the nitrogen consumption. And you see here, there are two results. For all countries, India, Indonesia, Vietnam, and the Philippines, the marginal physical product is increasing. But interestingly, it is increasing in Thailand. So when MPP is decreasing, the maximum yield will be achieved at N rate where the MPP N is 0. Meaning even if you add fertilizer, there will no increase in rice yield, given all the other factors constant at mean level. So in figure 4 here, maximum yield is when you apply 160 kilogram of N fertilizer. And if you apply more than that, the MPP will be negative. So, and this is because excessive N promotes lodging and plants become more attractive to insects and diseases. But what does increasing NPP mean? I interpreted this or it suggests a deficiency in N on most plants in Thailand. So use of an additional unit of N fertilizer could exert a positive influence on the yield. So N here is a limiting factor. So the main aim of the study was to explore the relationship among NPK and N fertilizer with soil fertility. So here, this is the table. Site here is AD is India, Kanto, Vietnam, Hanoi, SB is Thailand, and TJ and UP are both in India. And as shown in the table, the relationship of N, P, and K varies across sites. So NP are actually substitutes in this area, and PK also are substitutes in this area, and nitrogen and potassium are complements in India, in Thailand, and Uttar Pradesh in India. So if NP are independent, the NP and P requirements of the crops can be estimated independently and can be applied without each other, without affecting the effect of the other. And it's also possible that N might already be limiting in the soil and that adding more P would not contribute to the crop growth. But what does it mean when it says input substitution of N and P? So to look at it more here, I graph the P against the marginal value product or the marginal returns of N applied. So marginal value product is just the marginal physical product times the price of rice, the price of fertilizer. So if two inputs are substitutes, increasing the application of one nutrient reduces the marginal returns of the other nutrient. And here, as you can see, the red dash here is the price of fertilizer. And the MVP or the marginal return is higher than the cost of fertilizer at almost all levels of P in India. And this finding, I say, can support the practice of farmers of selective application of nutrients, meaning that when farmers are faced with cash constraints, they would prefer to buy the cheaper fertilizer. And compared to P fertilizer, N fertilizer is heavily subsidized in India. Hence, this adversely affects the consumption of P and K fertilizer. But I would say that while the substitution of N and P may be justified on economic grounds, this relationship needs further research or studies that support it from an agronomic viewpoint. And then another interesting result is the complementarity of nitrogen and potassium. Here, as you can see in the graph, this is the K fertilizer, and this is the marginal returns of the applied K. As you can see, up to this point, even if you apply fertilizer, you will have negative marginal returns of K fertilizer. Individually, N and K significantly decrease yield. So beta N is less than 0 and beta K is less than 0. But when they are applied together, it's positive. So a positive relationship between yield and K can occur only if the positive effect of K on the marginal physical product of N is higher in absolute value than the direct effect of K on yield. So what I'm trying to say is potassium must not be applied alone, but rather in combination with N. And given this, if farmers practice selective application, then or that is only applying N or K when farmers are faced with cash constraints, this might cause more harm than good to the crop. And then the next research question is the yield response to N dependent on the ex-ante state of soil? So this is just one example of the results, which is almost representative of all the results. So here, this is I graph here the plot carbon content against the marginal returns of the applied N. And this is from Indonesia. And as you can see, the marginal return is invariant, almost invariant to a C content level of approximately 13 grams per kilogram, and at which point the marginal return increases up to a C content level of approximately 21, after which the marginal return flattens out with no further statistically significant growth in rice yield response to N fertilizer beyond that soil fertility level. So the complementarity between soil organic matter and N fertilizer application might mean that N fertilizer application becomes unprofitable in soils depleted of soil organic matter. So poor soil fertility might actually be a cause and not merely a consequence of low rates of fertilizer use. Another interesting result is this in the Philippines. The marginal returns is rapidly increasing in all the Philippine sample plots. And the figure also suggests that a farmer, let's say with 15 grams of carbon content, would get more profit than a farmer with soil with 5 grams of soil carbon in his farm, given that they apply the same level of N fertilizer at the mean level, and the maximum yield will be achieved at N rate where MPPCN is equal to 0. Then, so is the von Liebig the correct functional form? I will not discuss this all of these results, but The non-nested tests rejected the linear von Liebig model specification, except in one site in Aduturai, India. And the quadratic model outperformed all of the rival specifications, both in pairwise comparison as well as in a collective test against all of the alternatives. And in the case of a quadratic functional form, then profit maximization requires information for input and output prices and the marginal product for each increment of fertilizer. And rising fertilizer prices are a particular problem for poor farmers who cannot afford sufficient amounts of fertilizer. So in summary, the relationship among N, P, and K varied across sites. Some inputs are complements, substitutes, and some are independent. And soil organic matter significantly affects the economic returns on N fertilizer input in some areas, and input and output prices are important considerations in the Ssnm algorithm, given that the quadratic model specification outperformed von Liebig model. And my conclusion is that accounting for the nutrient interactions and the relationship between N fertilizer and soil organic matter can make the Ssnm strategy more adaptive to farmers' fields and will allow the integration of nutrient management techniques of maximum benefit to rice farmers. In addition, input and output prices are important considerations in the Ssnm algorithm. And the challenge now is for Ssnm will be to retain the simplicity of the approach, which is understandable to farmers and extension agents, while accounting for the above results. And because a focus on agroeconomically optimal input nutrient application rates can be misleading if it fails to note the importance of interaction among nutrients, and understanding nutrient interactions may provide as to why farmers over apply fertilizer or why they under apply fertilizer. So I say sound economic theory, data from high quality agronomic experiments, and proper statistical techniques should be combined in the development or improvement of fertilizer recommendations. And nitrogen fertilizer rate guidelines need to be more farm and site specific to raise farm profits, and this type of approach is likely to reduce environmental damage from the nutrient loss resulting from over fertilization. So where do we go from here? So one way to achieve this is to conduct more on-farm experimentation. On-farm experiments have been gaining considerable interests due to the availability of tools such as yield monitor, the geographic information systems, and remote sensing. Along with these technologies, advancements in data science have greatly broadened the scope of obtaining and analyzing data from farmers' fields and turning those results into site-specific fertilizer management recommendation. And the data from such on-farm trials would need to be combined with other kinds of site and time-specific data, which make up the current agricultural big data, currently so much a topic of discussion. Furthermore, the results of this study can stimulate not only the research scientists, IRRI scientists, but also policymakers to review the existing fertilizer policies in the study countries. To ensure the effectiveness of fertilizer policies, they must be targeted not only to match the needs, preferences, and resources of farmers, but also the interactions of the production inputs, because government, more often than not, focus on policies that are conducive to increased availability and consumption of fertilizers. So if nutrients are substitutes, then the decision of farmers about what fertilizer to use depend upon which fertilizers are cheaper to obtain and apply. And if they are complements, direct subsidies for these nutrients must be considered. For example, if N and P are complements, low subsidized prices for N fertilizer matched by similar level for P fertilizer reduces the probability of farmers practicing selective application when they are faced with cash constraints. And another is fertilizer subsidy or distribution might not be the appropriate means to support rice production in areas where soils have limiting organic matter content. And in such a case, government intervention might consider putting a greater emphasis on integrated soil fertility management and or adoption of soil conservation technologies. And before I end, I just want to say one limitation of this study. I know the results of this study only pertain to 1 to 2 years of experimentation. So if the crop response function to major nutrients and soil organic matter varies from year to year, the results are only representative for a given state of nature observed at certain point in time. So a multiple year analysis would be an interesting extension of this study. And this demonstrates a frontier where agricultural economists and agronomists and even soil scientists can work together. And thank you very much.
Thank you, Ivy. That was a very interesting presentation, and thank you also for the review on microeconomics that you provided. And of course, the beautiful picture at the end. Okay.
Aurora says hi.
Yes, yes. Okay, we're now ready to, we're opening the floor, virtual floor for questions. Anybody? You may unmute yourself and turn on your camera to ask your questions. Anybody on the audience or on Facebook? We also have viewers on Facebook. Okay, perhaps it's a lot to take in for some people. Ivy, we also have students in the Zoom audience today. I was curious. Let me start the ball rolling. In your conclusion, can you show your slide again, the last part? So I don't know. I'm not very familiar with all the countries that you've had your studies. Is it always the case that N, it's nitrogen, right? That N is the one that is subsidized. Is that right?
I haven't really looked at that, but in India at least, I know that N is always subsidized.
Okay, because for the policy implication, I was just wondering whether it's really for the government to subsidize a specific fertilizer, because as you said, it varies across areas, whether they are substitute or complements. But then you also said at the end that if they are complements, then a direct subsidy would probably be better. I was just wondering, because this is also the case of, whether the goal is increasing the welfare of the farmers or increasing the yield, right?
Yes.
So if that is the case, maybe the, prescribed policy better would be to an income transfer, a conditional income transfer,
Yes.
conditioned on farmers spending it on production.
On
If
production, yes.
the goal
Yes.
is increasing yield.
Yeah, I agree. And also, for us, usually economics, one plausible assumption is the increasing profits, right? But it can also be for environment as well. So yes, income transfer can also be a policy here. But I
Yeah.
haven't really looked on the policy side yet. I look more on the Ssnm formula,
Yeah,
on
of
the
course.
algorithm. And that can be an extension to review the existing policies and how Ssnm will affect this existing fertilizer policies, especially the study countries in this area are the top exporting and importing countries of rice, and the fertilizer policies, that these countries choose to take will affect the rice production through the global market for rice.
Yeah. So you said it's already in the Philippines, the approach, the SMN approach.
Yeah, I believe I was talking to Donald yesterday, Villanueva from Erie. He said this has already been turned over to DA, the rice research manager. And I see that Ate Rowena Castillo is here in the audience. Hi, Ate Weng.
Hello, thank you.
Hello, good afternoon.
So is it already, adopted widely, or it has just been introduced?
It's adopted already in the Philippines, and actually it's Ms. Rodriguez is correct that it's already transitioned to the Department of Agriculture. Can I continue with my comments?
Yes.
Yeah. I just noticed that you presented one equation for calculating for the fertilizers. Actually, there's a lot of improvement already in the SSNM approach. In the particularly in the phosphorus and potassium calculations. The equation that you showed earlier is based on the yield gain approach. The crop response. Right now, what we are adopting in the calculations of phosphorus and potassium is balance approach or nutrient balance approach, wherein we are considering the inputs coming from organic materials like rice straw, and also the one you mentioned on the nutrient inputs coming from irrigation water, and even addition of other organic materials. So that's for P and K. We don't really use yield gain approach for P and K because we see not so much response to P and K. But for N, we still use yield gain approach, but instead of using recovery efficiency, we're using agronomic efficiency for applied nitrogen. And actually, the 160 kilograms nitrogen that you said, it's the maximum, sort of something like that. But in the Philippines, I guess, around that value. And we consider that as high yielding already. What we observe in the Philippines, medyo ano pa at the lower rate pa for nitrogen. And actually, I was telling to my colleague also at Erie that maybe we can work with you because we have a lot of data already. Those farm evaluation trials that we conducted since 2013, we have more than 1,000 of data points already in the Philippines. So maybe we can, I don't know if we can collaborate
actually,
on
before,
that.
I was talking actually with the Research Council of Norway, before, like 10 minutes before I go online here. And I was asking there, is there a possibility to host, or me going there, or you coming here to work together, and they said yes, there we have a fund, and the call will open sometime later this year. So hopefully, if you agree, maybe we can work on this together in a possible extension of this study, because it would also be interesting to compare the actual SSNM recommendation with the results of the production estimates that we have analyzed using newer data sets and bigger
Yes.
data sets. Yeah.
Mhm.
And perhaps you can include graduate students also.
Yes, yes, yes. We actually, the PhD and MS, we have funding. Call for that as well, that they can come here and do their PhD, or at least just do the research,
Yeah.
and that's a possibility as well.
Because I think this kind of research is not just a one-time thing, as it
No,
is
no, no. It
several years,
evolved.
right?
Yeah.
Several years, because of you do a lot of experimentation. So
Yeah.
And as Ate Rowena says, there are a lot of improvements since my review. So yeah.
Mhm.
so that's good news for the students who are on the audience, because you
Yeah.
already have a lot of data on that, right?
And I have data sets also from India. So please contact me if you want to
Yeah,
work with
there
me on
are
those data
there
sets.
are a lot of data collected beyond the years that you have that
Yeah, mine was
in
is yeah, that's the
the
limitation. It's
2000.
only from 1996 to 1999, and it
Yes.
was given to me by Dr. Akim
Mhm. Okay.
and Dr. Duresh.
Okay.
So since you are here, Rowena, no, from Erie, so if our students would like to request for data from Erie and would like to do study, they can contact you. Is that right? Okay, oh, that's good news. Because students would always like to have data for their thesis or for their dissertation. That would be good. That's good news. Thank you, Rowena. Okay, any questions? Any other questions from the audience? From our Zoom audience? Or comments? Let me just roll this screen. Anybody? Yes? Is there somebody?
No. Let me see. Oh, Eugene is here also, and Donald.
Are they from Erie?
Yes.
Okay, so Ivy, this kind of study, I guess, would take a lot of funding, right? So it's not like doctoral students would do this for their dissertation. What can you say about this?
You can do that. If I can share my screen again.
Yeah.
Can I share my screen again?
Yes, I think, yes.
Here, do you see this? This is the Research Council of Norway, and we have funding for research abroad.
It's not
And
shared.
is it not shared yet? Okay. How about now?
Yes, okay.
Here, it's the Research Stays Abroad call, and this is specific actually for doctoral and postdoctoral fellows. And as you know, Ate Mahay, in Research Council of Norway, every year we write proposals.
Mm-hmm. So it doesn't mean that they have to study there. Is that right? So they are.
No, it doesn't mean they have to study there. They can actually select the school they want to attend. We have one. We have post PhD right now, but she's enrolled in NMBU, but she's spending 6 months in Texas A&M to do her dissertation.
So it can also be our current students.
Yes.
Getting funding from this. Oh,
yes.
Okay. Oh, that's good news.
But I have to explore this more for the criteria and the requirements and eligibility.
Yeah. Okay. Oh, that's
also
good.
postdoc. Do you have postdoc?
Yes, postdocs.
Kasi we have fresh PhD graduates, Maha.
Mm-hmm.
Baka
this
pwede
is
sila.
Lina Tan, one of our faculty.
Yes.
Yeah, Lina.
Yes. Hello.
Yeah.
Yes,
Hi.
postdocs, this is for both doctoral and postdocs, and actually
Hmm.
even researchers themselves.
Oh,
And the
okay.
condition, visiting researchers. I think the only condition there is you have to have a PhD if it's a visiting research,
Mhm,
a
mhm.
researcher application.
Okay, so that would be a good opportunity even for faculty.
Yes,
How long
yes,
is the
yes.
grant? Mga 1 year for postdoc? Is it 1 year?
It says from 3 to 12 months.
Oh, so pwedeng 12
12
months.
months. And it can
Pwedeng
be
1 year.
like, I mean, 3 months muna, babalik.
Oh,
Tapos,
okay. That will
That's
depend on the
better.
study.
it can be divided in shorter segments.
Mhm, mhm. Okay.
Yeah, kasi they can take courses there. Tapos gather data in the Philippines. Tapos
Yeah.
with data, they can go back there
Yeah,
and
yeah.
help and get help analyzing the data, right?
And actually, one of our PhD students, they take courses in the US, but they
Mm,
enroll in Germany. And
mm,
then they do their dissertation here.
I see.
So as long as the funding allows, it's okay. As long as the budget is sufficient, then it's fine. If the course that you want to take is available elsewhere, then there's flexibility.
Mhm, mhm. So that's good to know.
Mm.
Up to what extent yung economic analysis nyo?
This one,
Yeah, and even what else can you do pagka yan? Like for instance, kaya nyo
here,
bang, yeah.
yeah,
I'm sorry.
another extension of the study is the multi-year, because as I said earlier, the limitation of this study is only 1 to 2 years. So if the results varies from year to year, then this only represent the results on that particular period on time. So it would be good to extend it to a multi-year analysis. And what's interesting again is to compare the actual recommendation of SSNM to the results of this. And maybe we can extend, like Ate Maha said earlier, to review the policies as well, because the interaction of nutrients varies from site to site. So maybe the fertilizer subsidy is not the appropriate policy, but it can be because of the soil organic matter, the fertilizer effectiveness of N fertilizer is dependent on the soil organic matter. So the right appropriate policy would be to promote conservation agriculture or the integrated soil fertility management. So it can be on the policy side as well. Like I said, it's not only for the IRRI scientists, but also for the policymakers to review the existing work.
Thank you.
Thanks, Lina. We have somebody raising his hand, Donald.
Hi, good afternoon. Thanks, Ivy, for comprehensive presentation.
Miss Ivy.
I'm
So
also,
you're the one from Erie. Is that
Yeah,
right?
he's my friend.
Oh,
I'm also from Erie. So I am also involved in the monitoring evaluation of the RCM, the Rice Crop Manager, under Weng, under Wen. Maybe the question is for Ivy and for Weng. So in case that we change, we realize that the old formula, the new formula is better than the old formula for profit maximization. Then what will be the implication?
Donald, I can't hear. Can you come
Sorry.
closer to the mic?
So if we find out that the new formula is better than the old formula, and we already transferred the database and everything, the rights or DA. So what will be the implication in terms of logistics? Maybe
DA would not like it. I
yeah.
think
So
that's
what
the
will be
first implication if we say, oh no, we have to change it. But I think because this is an evolving process, and we, like Ate Rowena said, you make improvements from time to time. So I guess my suggestion earlier is on-farm experimentation, but I am not sure if it's doable in developing countries like the Philippines if we use yield monitors, remote sensing, and GIS. So it's not possible. But we have a project in India. They also apply. I think you also work with the Indian Rice Research Institute, INNR or something. But what they do is to measure the soil health, because in my results, soil health is very important for the efficiency and fertilizer. So what they introduce now is they have the soil health card for farmers, because soil fertility also is another big topic right now. So they help farmers to monitor the soil health of the farms. So, and it's not very expensive. You just provide soil health. So maybe you can, I'm not sure if you're doing it already in the Philippines, the soil health card monitors.
I don't know. I'm not there. Yeah. So regarding the proposal that they collaborate with IRI, then maybe I can help as well in
Hmm.
analysis.
Yeah.
Thank you.
Like I said, it would be nice to collaborate from the beginning, the agronomist, ag economist, and maybe soil scientists to do the fertilizer recommendation algorithm. And that's what I have been trying to do also here in IBIO. But it takes time to integrate our results, but we're getting there, hopefully.
Thank you. Thank you.
All right, thank you. Thank you, Donald. Okay, it's almost time, I think. We don't have any more time for discussion, but before we go to the most awaited part of the seminar, I'd like to invite everyone to the next season, because this seminar is the last seminar for this semester, or we call it season. So next season, this is season 4, I think. Let me invite everyone. So from August to December 2022, we already have the lineup, starting with yours truly. Then we also have Dr. Louis Dumlao, Dr. Lina Tan, Dr. Jeff Ducanes, Dr. Butch Lansona, CJ Castillo, Dr. Alvin Ang, and Dr. Mayre Magante. So that will be our next seminar for the next semester. And for those of you who are looking for the recording of the previous seminar, it's in our YouTube, the Ateneo de Manila YouTube channel, and you have here the playlist. So make sure to go to the playlist, and all the seminars are uploaded already in the YouTube channel, Economic Seminar Playlist. Okay, and